So here is question number 6 everyone. A particle moves along path y equals ax square where a is constant in such a way that x component of its velocity ux remains constant. The acceleration of particle is what? Now since it is clearly mentioned that component of velocity along x is always constant, it means acceleration must be perpendicular to x direction. So we can say that acceleration is toward y direction. Now y is already given, y equals ax square. We can calculate the component of speed along y direction, that is dy by dt uy, which is equal to 2ax dx by dt. What we are getting? Uy equals 2ax dx by dt, the component along x direction, that is already given ux. Now differentiating uy gets us acceleration toward y direction. So therefore ay will be 2a. X will be written as dx by dt because we are differentiating with respect to t. Ux is constant, so it will be written as it is. So we will get ay as 2a. This is ux, already there is ux, so ux square. Direction we already have got, that is along y. Therefore acceleration will be 2a ux square j cap. Option number 3 is absolutely correct, so we will go with option number 3 only. Now move on to the next question, that is 7 number. So this is question number 7 everyone. A train appears to move northward with speed 20 under root 3 meter per second to a man sitting in a car moving eastward with speed 20 meter per second. The velocity of train with respect to ground will be what? Now according to question, this is the man moving with speed Vm with respect to ground, and that is 20 meter per second. And with respect to this man, the speed of this trains appear in north. So speed of train with respect to man given 20 under root 3 meter per second. Now we have to calculate the speed of train with respect to ground. Now according to the relation of relative velocity, we can write the speed of train with respect to man in vector form can be written speed of train with respect to ground minus speed of man with respect to ground. So from here, the speed of train with respect to ground, we have got vector sum of speed of train with respect to man plus speed of man with respect to ground. So VTM vector is this, VMG vector is this. It means their resultant will get us speed of train with respect to ground. Now the magnitude can be written simply VTG as under root VTM squared, that is 20 under root 3 square plus 20 square, which gets you after solving 40 meter per second. Now the direction of speed of train with respect to ground will be given as tan alpha, where alpha is the angle resultant making with first vector. This is alpha. Will be what? VTM upon VMG. VTM upon VMG. 20 root 3 upon 20, that gets you root 3. Therefore alpha will be 60 degree. 60 degree north of east. So therefore we can say that 60 degree, that is we can see from the diagram 60 degree north of east. We have to go with option number 3, which is absolutely correct. Now move on to the next, that is question number 8. So here is question number 8 everyone. A horizontal acceleration A that should be given to a smooth inclined plane of angle theta equals sine inverse 1 by z, where z is greater than 1, to keep a block stationary relative to the inclined plane as shown in figure. Now, the system itself is moving on which another block is kept. So this is the case of pseudo force, non-inertial frame of reference. So let us draw the forces acting on the block. Its weight will be vertically downward. Component of weight, that is mg cos theta right here, mg sin theta right here, normal reaction this direction, and since the frame is accelerating in right direction, so the block kept on the frame will experience a pseudo force in left direction, and that pseudo force will be given by MA. Now this is MA, mg, mg sin theta, mg cos theta, as this is theta. Now break the component of MA as well. One component goes along this direction and other component goes along right here toward mg cos theta direction. So therefore we can write this is theta, so this angle will also be theta. So here this component will be MA cos theta and this one MA sin theta. So these are the forces acting, and since block is at rest, so we just can write mg sin theta. Block is at rest means it is not moving. It means mg sin theta will be balanced by this MA cos theta. So mg sin theta is balanced by MA cos theta. Cancel out. We got the value of A, that is g tan theta. And since sin theta is given already in the question, sin theta is 1 by z. So from right angle triangle we can calculate tan theta as well. Theta perpendicular upon hypotenuse. So one is perpendicular, z is hypotenuse, base will be z square minus 1. So therefore acceleration will be g into tan theta is perpendicular upon base. So 1 by under root z square minus 1. So this is the acceleration we have got. It means we have to go with option number 1, which is absolutely correct. Now move on to the next, that is question number 9. So here is question number 9, everyone. Two blocks are connected by a long inextensible string passing over an ideal pulley as shown in figure. If the system is released from rest, then the common speed of blocks when block M2 moves a distance capital L will be what? Now it is clearly mentioned that this M2 has moved by a distance L, and since the string is inextensible, so the M1 will also move by distance L. Now let's apply the concept of work energy theorem. According to work energy theorem, we have work done by conservative forces on the system plus work done by non-conservative forces on the system plus work done by any external force acting on the system will be just change in its kinetic energy. Kinetic energy final, that is half. Now they are connected with the string, so they have a common velocity. So their kinetic energy combined can be written as m1 plus m2 v square. Initial k is 0. Now we have to calculate this v actually. Work done by conservative force. M2 is going down. So here work is done by gravitational force, that is m2gl, plus work done by non-conservative force. Friction is acting right here. So block is going in right direction. Friction is acting in left direction. So negative work done. That's why minus mu m1g, value of the friction force, into displacement L, equals half of m1 plus m2 v square. Now we have got m1 plus m2 v square equals 2gl, taking common m2 minus mu m1. Therefore the value of v which we have got is under root 2gl within bracket m2 minus mu m1 divided by m1 plus m2. So this is the final expression for common speed we have got, and we can say that option number 3 is absolutely correct. So we can go with option number 3. Now move on to the next, that is 10 number. Here is question number 10, everyone. A ball of mass m moving with velocity vector v collides head-on elastically with another identical ball moving with velocity minus v after collision. Now it is clearly mentioned in the question that the type of collision is perfectly head-on elastic between two identical balls. So therefore we know very well that for elastic head-on collision between two identical balls, their velocities are exchanged. So for example, let us try to understand the question from the simple diagram. This is A, this is B. So both are identical, and the speed they have, this is vector v, then this will be minus of vector v. After collision, what will happen? Their velocities will be exchanged. It means the first one will get the velocity of second one, that is minus v. On the other hand, the second one will get the velocity of first one, vector v. Let us read the options. Both ball comes to rest. Wrong. One ball come to rest, other ball travel back with velocity 2v. Incorrect. Both balls move at right angles to their respective original direction of motion. No. Absolutely wrong. Both balls move at an angle of pi to their respective original direction of motion. Definitely. They have changed their direction by 180 degree. They just have reversed their direction. So we can write one sentence here. For elastic head-on collision between two identical balls, velocity will be exchanged. So fourth one is correct. We'll go with option number 4 only. Move on to the next, that is 11 number.